Hey guys, and welcome to a new video. In this video, we're going to do instance segmentation. So we're going to use PixelLib to do instance segmentation on both images, but also videos. I'm going to create a bunch of videos with this PixelLib library for instance segmentation. We can do like background subtraction, live instance segmentation with a webcam. We can both do inference on like images and also videos. I'm going to code it out. I'm going to show you how we can actually like download it. I'm going to show you how we can use it, and then you can try it on your own computer. So first of all, here we'll just go inside the GitHub repository. Here we're just going to scroll up to the top. So we're going to use this PixelLib library, which is basically just here on GitHub. This is called PixelLib. It is used for or like supported by PyTorch. We can see some different kind of like results where they're compared to mask RCNN. So this is actually like a pretty good model, the mask RCNN, but now we are actually like using this a PixelLib, which is using this PointRend, where we can just see like the results. They're just way better. Here we can just see like all the edges of the objects that we actually like want to segment out in the image. We just get way higher accuracy on that. So we can just see that the results here for PointRend is really good. And this is the neural network that PixelLib is using for instance segmentation. We can use it for a lot of different kind of things, background subtraction, so we can get a really nice background subtraction. We can use it for live instance segmentation, which we're going to do in another video, where we're basically going to open up our webcam and then we just do live inference of a number of objects. If we just scroll down a bit, we can see how to install PixelLib. We basically just need to copy paste in these 3 different kind of commands into our command prompt. In this example, I'm using Anaconda as my Python distribution. So I'm just going to open up an Anaconda prompt, and then we can basically just copy paste these results into it. So here we have my Anaconda prompt. Just hit copy paste. I already have my requirements satisfied. I've already installed it on my computer. And then we also need the PixelLib. We just copy paste in these 3 lines of commands. And then we just paste it in as well. So here we upgrade. Now we need 2 dashes for the upgrade here. So now we're basically just going to upgrade it. So we need to like delete this one here and have 2 dashes, and then we hit upgrade. So now we have actually like installed PixelLib after you have ran these 3 commands in your command prompt or in your Anaconda prompt. And now we actually have everything installed, and we can jump inside Visual Studio and actually like do the coding. So this only takes a couple of lines of code to actually like run this instance segmentation. So first of all, we're going to import PixelLib. So I'm just going to call that import PixelLib. And then from PixelLib, we can actually like .instance, or like we can have our torch backend because we want to use PyTorch. So here we're just going to type out PixelLib.torch backend. And then inside of torch backend, we have this instance. So we're just going to type it out. So we have our instance, and then from our instance, which is our instance segmentation, we can just import instance segmentation. So I'm just going to tap that. And now we actually like have everything included here, or like imported, and now we're ready to use the instance segmentator from PixelLib. So we only need to like throw in a couple of lines of code. We need to have some images that we want to go through. So these are the images I want to pass through our instance segmentation model. So this is the first image, and this is the second image. And then in another video, we're actually going to do with a live camera. So definitely hit the subscribe button under the video here, and also the bell notification, so we get a notification when I upload a new video. We're going to do a ton of videos with this instance segmentation model. We're going to do background subtraction and all those different kind of things. It's really cool, and it's really easy to set up, and you can try it out on your own system. So we have our instance segmentation. Now we're going to set that up. So we're just going to have our instance. So here we have our instance. We just set that equal to our instance segmentation. So again, I'm just going to type it out. So we have our instance segmentation. So basically we just initialize our instance segmentation class. And then inside our instance model, I like just call it model here instead. So we have our instance model. So I'm just going to have model, and then inside our model, we can call load model. Now we just need to specify what model that we actually like want to load. We can have like the mask RCNN as we saw in the examples and out results in the GitHub repository, but we can also use the PointRend, which we're giving some really nice results. So we're just going to type that out. So we have the PointRend, and then we have underscore ResNet 50. So this is the ResNet 50 architecture, where we basically just have like 50 residual connections, or like 15 residual blocks. So this is the ResNet architecture. I have videos about that, like covering the ResNet architecture. Why is it good? Why are we using that as a backbone in a lot of pre-trained models? Because like ResNet 50 is actually like a really nice backbone for like finding features in images, and it's basically used for most backbones in like neural networks and pre-trained models. So we have ResNet 50.pkl because we're using Pickle to actually like save and load our models. Now we can set up our target classes. So we have target underscore classes. We're going to set that equal to model dot select target. Again, we're just going to type it out. Target underscore classes, and then we can actually like just set person equal to true. So here we actually like just want to detect a person for our selected target class. We can also specify other different kind of like labels, or we can just detect and do segmentation of all the different kind of like instances that we have in our image. We can also do semantic segmentation with these models, as I'm going to show you in another video. So this is actually like really nice, where we can do semantic segmentation, where you basically just assign a label to all the objects and even the background that we have in the scene. So now inside our model, we can actually like go in and do the actual like segmentation or do a prediction with our model. So we're just going to call segment frame or like segment image, because we're basically just going to load in an image. First of all, we need to specify the path to our image. I just have this image inside of my directory, the same directory as my instance segmentation Python file. So we're just going to type out the path. So it's a JPEG file. You just see the file up here at the top. And then basically we just have a lot of different kind of like commands here that we can set. These are just the default ones. I'm just going to choose the default ones. So we have to show bounding boxes. We want to show like bounding boxes around our segmentations. We specified the name of our output image. And then our segment target classes here is equal to our target classes, which is basically the target classes that we select up in line 6 here above. So basically, I'm just going to tap this one out here so we get all the parameters. And now we're actually like ready to run our program, see the segmentation on these two images. We're going to do it with the first one here to start with. But basically, I can just go up here and run the program, and then we can see the results. So here I'm going to run the program, and then we can go in and open up our results. So here the checkpoint state key contains key that are not used by the model. Here we can see some different kind of things. We get some warnings, but it will actually like run the code, and then we can see the results over here to the left. So our output image is actually like image underscore new. So let's just go down and find that. So we have the results here. I'm just going to close this one here and minimize this so we can actually like see what is going on. Let's see if we're actually like able to segment out like most of the persons in our image. So again, if we just go in here, we just set select target classes person equal true. So we only want to detect people in our image. We can see we get really nice like confidence score of these persons that we're detecting. We also get a really nice segmentation mask of our detected persons. Here we can just zoom in a bit, play around with it. But here again, we can see we have 97% confidence that this is actually like a person walking. Again, you can see the segmentation mask, like just all the edges here, all the boundaries of the persons is actually like segmented out. We can just see the details here, like look at this person here. We can maybe just zoom in a bit more, go over to the left, zoom in even more. But you can just see like the pixels here at the edge of the segmentation mask. So again, this is a really good instance segmentation model compared to like the mask RCNN that I showed you the results of in the start in the GitHub repository. Again, just even here, we can see that this could actually be a person, but again, it is really hard to see like this. It doesn't really like detect this person here, but also we can see that it is only like a couple of pixels. We have some black pixels here, and then we have like some colored pixels up here as well. So again, we get really high confidence score. Maybe this is also like thresholded out. Here we can see we miss a detection as well. We also miss some over here in the background, but this is almost impossible to see. We even see like a person up here at the top right corner, and we can see that it even has like a 50% confidence score that this is actually like a person walking up here. So again, this is crazy results that we get. We can also go in and do it on videos. Here we're just going to run it for the next image as well. So this is a bit more detailed image. We have a lot more like people walking around in the background here. We also have a guy on a bicycle. So basically, let's run the second example here and see how that works out. So that is image 2. We're just going to override our image new. we're going to run the program again, and then it will like do the segmentation of our image. One of the good things about this model is that it is really fast. Like we can get up to like 30, 40 frames per second when we're actually going to run this model on a live webcam, do live inference and all those different kind of things. Also, if you just want to do segmentation on individual images, it is also really fast for doing inference. So now it has actually like run the model here, or like the image. It has done the segmentation. We can then go into image_new and see the results. So here I'm just going to zoom out. So here we can see the results for this segmentation. Again, really good segmentation of our person here. To the left, also the guy on the bicycle. We can see the persons in the background, even some persons sitting down here at the stairs. It also detects the person here on this like ad or like this poster in the background. We can see it detects some people in the background as well, but again, it is a really high confidence score that it has. We have 97 over here, we have 99, 96, 70, 63, 93 over here at the end. I can also see we have some 97s over here in the background, 60s. So again, this is a really good model. It doesn't really detect like the people inside the car, but they're pretty much impossible to see. We have some people here that it doesn't really detect. I'll just zoom into it. So it is able to detect the persons like over here to the right, but here it has some difficulties. Again, it is really hard to see, like even like maybe like the human eye, we can see that these are actually like persons that it should have detected. But again, it is still really high accuracy that we have on this model. And again, if we actually get the detection of the person, we get this really nice segmentation mask around the edges. So we can just see the shoulder here of this guy on the bicycle. We can see the helmet. It is just a perfect segmentation. So even this guy here is wearing a helmet. It just does a really good job of segmenting out the correct classes. So that's pretty much it. We have been through like these two different kind of examples. So now we're going to see how we can actually do this on video. So now we have done it on images. Now we can do it the exact same thing just with videos. So I'm going to show you the video that we're going to actually pass through our model. But basically, we're just going to open up this video and see what we're actually going to pass through our model. So now we can throw that video through our model. We just go inside our model, then we can have a function called process video. We basically just specify the path here, the output name to the video file, and also the classes that we want to segment out. And we also want to show the bounding boxes as well. We also need to specify the number of frames per second that we need in, or like that we want in our output video. So we have frames per second here. We're going to specify that, set it equal to 30. We have a comma. Then our video is called intersection.mp4. We want to show the bounding boxes, frames per second, output video name, and also the segment target classes. Now we just hit save and we can run a program, and then it will like pass the video through this instance segmentation model, do all the instance segmentations, and then it will create a video with that. Here we can see that the program runs. Now we should actually just take in the individual frames. So here we see the number of frames, 1, 2, 3, 4, 5, 6. It's basically just extracting all the individual frames in our video, pass it through the instance segmentation model, and then when it's done, we'll get the output, and then we can play the new instance segmented out video with all the persons walking around in the intersection. So while it's running through all these frames, I'm just going to copy paste all this code. We're going to create a new Python script so we can actually see how we can do segmentation without like a specific class. So we want to choose this select target classes. We don't only want to detect persons in our frames or in our image. So we're going to create a new file. We're just going to have a Python file here. And then we basically just called that test. So we're just going to do that while the other program is actually running. So we're just going to minimize that. And then we basically just copy paste it in here. We have a PixelLib, we have the instance segmentation model. We do the exact same thing. Here we're just going to do it on the individual image. And then we have image 1 and image 2. So we're just going to go with the first image. We specify we want to show the bounding boxes, output images, and then we just delete this segment target classes, and then it will like do instance segmentation on all the classes that this model has been trained on the Coco dataset. So this is actually like a lot of classes that we can do instance segmentation of in our images. You can do the exact same thing for the video if you want to like detect any instance or like any object in your scene or in the video, where you can basically just delete this. And now we actually like just add 3 lines of code. We create our instance model, we load the model, and then we segment out our image, specify the image, the output image, and so on. And now we're going to do instance segmentation on all classes from the Coco dataset, and not only like a single class as a person, for example. So now it's done processing all the frames. We can then go inside the file explorer. So this is the output video underscore new. We can go inside the file explorer and see the actual like results. So here we can see the results. We get 30 frames per second. So it's basically just detecting all the persons here in the image. So, or like in the video frame here. So it's just taking the individual frames from the video, extracting that, and then it's segmenting out all the people here in the intersection. So this is actually like really nice results that we get. We can see we get really high confidence scores, up to like 90% confidence score on all the people here walking around in the intersection. This is a really chaotic intersection, but again, we get some really nice instance segmentation mask around the people that we're detecting. I also did this video here with only 3 frames per second, so we can just see that to see the results. So this is the intersection underscore new. So here we can just see we get 3 frames per second. So this makes it a bit easier for us to see what is actually going on. But we can see here the crosswalk, we get 99% confidence score of the people walking on the crosswalk. Again, really nice segmentation mask around the people, even on bicycles and like scooters. So again, really crazy model. We're going to see how we can do it with like a live inference, so we can do it on our own webcam. I'm really excited for that. So again, make sure to hit the subscribe button and bell notification under the video. So really awesome model, get some really nice results. You can try it out on your own. Here we're just going to minimize that and see the results for the other model, where we're not only going to detect the persons, but just any object from the Coco dataset. So we created this test.py. We have the same model, we just load in the image.jpg, and now we're not specifying any segmentation classes that we want to extract. So basically here we just run this program, have 3 lines of code, create our model instance, load model, and then we segment out our image. So now we basically just throw it through the model. Now we can see that we have done the instance segmentation. The output image here is image underscore new, and then we should be able to see that it can detect all the classes in our intersection. However, image underscore new. I'm just going to open it up here, and then I'm just going to zoom out. So here we can see now we're detecting every single class and every single like object in our intersection. So we both have cars. Before we only have like persons walking around. Now we have a suitcase here. We have car, traffic light, fire hydrant, a bicycle, handbags. Like even we can see here that the people or like persons walking around with handbags. Really high confidence score, like 82% confidence score that this is a handbag. We can see the cars over here in the background. Here we miss a detection. We see like the persons, bicycles, cars. Like this is a really nice instance segmentation model. If we just zoom in here on the car, we can just see this really nice, like the edges of our instance segmentations here are just like extraordinary. They're like just amazing. Like these results are just amazing, and we still get a really high confidence score of 83. We get this bounding boxes that are fitted around the instance segmentation mask. Or again, if we just zoom out here a bit, we can see there's a really nice result. Again, I'll just want to try it with the second image here as well. We're just going to run it and see the results for that, just to verify that we also get some really nice results and maybe some other classes in the other segment or in the other intersection. Here we're just going to have our image new again. We're just going to open that up as the last thing for this video. So here we can see the results. We get a bit more dense representation with our segmentation mask, but again, we can even distinguish between these 2 cars. We can just see the edges of these cars that we're actually like detecting. Here I'm just going to minimize that, and over here. But we can just see like it's just really good at actually like distinguishing between different kind of like instances in the image. The bicycle, the person on top of it, we have the persons in the background, person here, we even have like a traffic light up here to the left. So this is a really crazy model. We get some really nice results. You can basically just go in, pip install it with 3 commands in your command prompt, run these couple of lines of code that you need. You need to set up your model, load the weights of your model, and then you basically just need to do like a forward pass of that image through the model. We get some really nice results. It will do everything for you. It will even do the visualization for you. We're going to cover this way more in future videos for background subtraction, live inference on a web camera, where we're going to see some really nice results. And we're even going to run live instance segmentation in real time with up to 30 frames per second. So thank you guys for watching this video here. And again, remember the subscribe button and bell notification on the video. Also like this video if you like the content and you want more in the future. This really helps me and the YouTube channel out in a massive way. I'm currently doing a deep learning tutorial if you want to know the basics about like how we're actually creating neural networks from scratch, all the different kind of like hyperparameters, how we can train them, different kind of like neural network architectures. I even have videos about like the ResNet architecture, which we've been using in this video. So if you're interested in that tutorial, I'll link to it up here, or else I'll see you next video, guys. Bye for now.